So the fact that I've blown out my car speakers now 2 cars in a row, what does it say about the signal processing?
Is it your fault, or is it the fault of the system designer who didn't put the signal processing in place in order to prevent you from doing that?
All right, almost Dr. Castro.
Yeah.
I know you've been working very diligently on your dissertation. Mm-hmm. So could you please define to me what is signal processing and how does that impact audio quality? Because I've heard that a lot of times, signal processing, but I've never really properly had it broken down of what does it mean?
Yeah, we do signal processing. Probably most everything you do or you've ever used has signal processing. Your phone's got signal processing, your laptop's got signal processing, everything's got signal processing. There comes a time when like the speaker itself just cannot perform past physical limits. So we have to just adjust the signal in order to kind of help it out at the parts where it's not performing very well. For example, your phone speaker is so tiny that there's no way it should be able to reproduce all those like larger waveforms. Like of human voice at 500 hertz is actually a pretty big sound wave. And you know, the little tiny highs and stuff like that, like the cymbal crashes and the sibilants, no problem, right? Your phone, any tiny speaker can create those because it doesn't have to move back and forth very much. But when you have to start moving back and forth a lot, that's when you start getting into the problem of like, hey, physics is stopping me at this point right here. So signal processing comes in to say, hey, we can take the signal, I know what you're trying to do, I know what you want to hear, and then we can basically do some trickery and do some really complicated mathematics to be able to duplicate, double the signal, put it underneath, create extra harmonics and do whatever to be able to make sure that by the time it gets out to the person who's listening to it, it sounds more or less what you're expecting. So that's signal processing, and it can happen on both the way in, so you can process a signal coming in. So if you have a microphone, you can actually process the microphone, so that way by the time it transmits to you, all the low rumble is taken out of it. Even this ultra high information that's just wasting information and data is taken out. So you're just having the relevant parts of information get through it. And then on the production side of it, that's when you can have the speaker taken care of, so that way as you send a conditioned signal across it, it will perform as you'd expect from a good speaker.
Got it. And can you use signal processing not only to improve audio quality, but also to do things like protect speakers, to configure audio within a space? Because obviously each speaker independently might impact a space. What are the different touch points where signal processing becomes useful and when it's like a must-have needed thing?
Well, and the cool thing is that you can think of signal processing not just for audio, but like think of like a machinery on like a line, a factory line, right? Something is stamping something and has to stamp it 3 times. Boom, boom, boom. It has to be exactly the same, 1, 2, 3. But if 1 is really strong, 2 is not very strong, but then 3 is strong, then you can use signal processing and say, okay, by the time you hit the second oscillation of that one, put a little more emphasis on that one, so that way all of them come across evenly. And I think that's probably the easiest way to understand what signal processing is doing to it at the same time. And at the same time, even like a machine and like a speaker is basically something that goes back and forth as well. You can put protections on how far it goes before it'll stop. So that way you can stop the speaker from going too far where it goes past its physical limitations and perhaps pops or perhaps hits the edge of it and it doesn't sound very good or anything.
So the fact that I've blown out my car speakers now 2 cars in a row, what does it say about the signal processing?
Is it your fault, or is it the fault of the system designer who didn't put the signal processing in place in order to prevent you from doing that?
I like my bass. So unfortunately, that's where it's gone. But that makes a lot of sense.
You like breaking things too, so that's also...
It's a balance, but I ensure highest quality of a product, and if it doesn't match that requirement, unfortunately, it will not survive with me. But
Val test.
Exactly. It has to be Val proofed.
Anything comes out, it's been Val tested, and trust me, nothing is harder than the Val test.
But I appreciate you breaking it down, but that makes a lot of sense. So signal processing at the end of the day is controlling the signal to allow for the delivery mechanism to create the maximum output it can possibly do, and correct if necessary, limit if necessary, but that is independent of what the device itself is intended to do. It's more about manipulating to allow for that to maximize its yield.
That's right. And you want to know something kind of crazy? That only exists if we all agree to accept that audio has to exist in this one channel. The minute you take audio and put it somewhere else, or you have some other different type of input source that's not a microphone, or you have an output source that's not a speaker, all of that goes out the window. Because then at that point, you're dealing with other things that don't engage the same auditory senses that we're used to seeing. So, you know, in the case of the machine, it's not a big deal. It's a very small amount of things you have to change, right? It's a very finite system. But say you're trying to recreate an audio system or recreate a high fidelity or high bandwidth system elsewhere, a mechanism elsewhere, then all that signal processing that exists for this one niche type of bandwidth, you have to basically reinvent from scratch to try to see if you can get it with a whole new slew of physical limitations that you just don't have on the other side.
Math is fun. Sounds like those that have to figure it out got to understand math, but appreciate you breaking down signal processing.